Hi, Mid 3. I hope that you are fine. Today we have lesson 3, unit 1, which is physical quantities, scalar and vector. First, let's know what meant by physical quantity. The physical quantity means any quantity that can be measured and has measuring units. Can be measured, for example, the length. Can we measure the length? Right. We can measure the length. If we determine the length of any object, it may equal 5 centimeter, for example. So we measure the length and we found it 5, and centimeter here is the measuring unit. So we can measure it and has measuring units, so the length is considered physical quantity. But physical quantity have two types, which are scalar and vector. First, let's know what meant by scalar and vector. Any physical quantity, as you know, has magnitude, and magnitude means the numerical value, the number, and measuring unit. For example, the measuring unit of length is meter or centimeter, the measuring unit of energy is joule, the measuring unit of mass is kilogram, the measuring unit of area meter power 2 or centimeter power 2. So any physical quantity must have a numerical value and has measuring units. But also we may need direction or not. If we need direction to describe the physical quantity, we can say it's considered a vector physical quantity. But if we don't need direction to describe the physical quantity, we can say that is a scalar physical quantity. For example, if I asked you to determine the length of object, you can say that 5 centimeter, right? Only, but you don't need to say 5 centimeter east direction, right? There is no need for the direction here. If you determine the mass, if you measured your mass, you can say I'm 70 kilogram. But it's considered abnormal to say that I'm 70 kilogram in west direction, for example. You can say that only I'm 70 kilogram only, but no need for direction here. So no direction needed. And if we don't need direction, we describe it as scalar physical quantity. And the scalar physical quantity is a physical quantity that has magnitude only and has no direction. Example of physical quantity, scalar physical quantity: temperature, speed, and the time, and the distance, radius, mass, energy, area, distance, and length. Give reason. If mass, length, and the time are scalar physical quantities. Why? Because they have magnitude only and has no direction. Number 2, vector physical quantity. But vector physical quantity must have magnitude and has also direction. For example, the weight. Weight equal mass times gravity, and gravity, the direction of gravity, as you know, is downward, right? So we have direction here. So weight is considered vector because it has direction. Number 2, force. Force considered the vector because if you act by force an object to move it forward or backward, or you can move it upward or downward, now you have direction, right? If you need direction, you describe this physical quantity as a vector. So force considers the vector, and also displacement and acceleration and velocity. So force and acceleration are vector physical quantities. Why? Because they have magnitude only or direction? No, you can say that because they have magnitude and direction. Number 2, distance and displacement. What is the difference between distance and displacement? If we have 2 points, point A and point B, now we need to move from point A to point B. We have 2 ways. We can walk in the shortest straight line between A and B, or we can walk in the curved line between A and B. If we take the shortest straight line between A and B, is considered the displacement. And if we take the curved line, we describe it as distance. So the distance is the actual length of path that moving object covers from starting point to ending point. But the displacement is the length of shortest straight line between starting and ending point. For example, if we have this in the opposite figure, A and B, the distance between A and B is 5 centimeters. So the distance between A and B is 5 centimeters. But displacement also is 5 centimeters AB direction. From A to B, then back to C. If we move from A to B, after that we back to C. So the distance between A and B and C, AB equal 4 and BC equal 2. So 4 plus 2 equals 6 centimeters. But displacement from A to C equal 2. Why? Because the shortest straight line between A and C is 2 centimeters. But if we move from A to B to C, the distance between A and B and C, AB plus BC. AB 3 plus BC 4. 3 plus 4 equals 7. But the displacement from A to C is the shortest straight line between AC. We take from Pythagorean theory, AC, we measure the hypotenuse here, right? This right angle. So the hypotenuse equals the square root AB power 2 plus BC power 2. And 9 plus 16, which is 5 centimeters. So if you compare between distance and displacement, you can say that distance is the actual length of path that moving object covers from starting to ending point. And displacement is the distance covered by object from starting point to ending point. We can determine the distance by magnitude only, number, and measuring unit. But displacement, we can determine it by magnitude, number, and measuring unit, and the direction. The kind of distance is scalar, but displacement vector. The measuring unit of distance, meter or kilometer. Also, the displacement measuring unit of it is meter or kilometer. Number 3, speed and velocity. What's the difference between speed and velocity? If the speed has a direction, so it considered a vector, a velocity. If the speed has direction, it will consider, or we consider it as velocity. Speed plus direction equal velocity. For example, if we drive a car from Alex to Cairo, and the speed is 120 meters per second. But if we say that the speed is 120 meters per second east direction, or Cairo direction, Alex to Cairo direction, now we describe it by direction, so it will be velocity, not speed. So the speed is distance covered by object in 1 second. The speed considered scalar because it identified without direction. But velocity is displacement covered by object in 1 second. And velocity considered vector because it is identified by magnitude and direction. The speed of cheetah is 27 meters per second. But the velocity of cheetah is about 27 meters per second in certain direction. If we describe the speed with direction, so it will be velocity. Give reason pilot take in consideration the velocity of wind. What the importance the velocity of wind for pilots? Because the direction of wind affects the velocity of plane and time of trip and amount of fuel consumed. When the plane take off in same direction of wind, the velocity increase and time decrease and fuel consumed decrease. In opposite direction, the velocity decrease, the time increase, and the fuel consumed increase. This is guideline to solve the problem on distance and displacement. If we move a complete circle, the distance is 2 by r and displacement is 0. If the starting point equal or the same ending point, so the displacement is 0. But if we move from A to D, 3 over 4 the circumference of the circle, so the distance here 3 over 4 times 2 by r, and here the displacement AD equals square root AM power 2 plus DM power 2. And if we move half circle, so the distance half times 2 by r, and the displacement is diameter from A to C to r. And if we move a quarter circle, 1 over 4 is circle, 1 over 4 times 2 by r, and the displacement also square root am power 2 plus mb power 2.